also there now. So we can, October has already started, and as our previous plan that November will be a bit pressure month because of the midterm in school. So we we should try to patch up these big chapters. Trigonometry, differentiation, integration we have started today. So this is chapter 13, and you have to do questions from this book, chapter 13, book 2. So just let me know if you are able to open the book. That is the only requirement, that to see if the PDF is opening. Meanwhile, we discuss this point that what is integration? Integration is part of calculus, and integration is the reverse process of differentiation. What is differentiation then? Differentiation is basically a technique of scaling down, a function. They are decreasing the power concept. Then what is integration? Integration is actually reversing it. So when you differentiate volume, it becomes area. And when you differentiate area, it becomes a linear side. If you reverse it, when you integrate area, it will become volume. So this is our first concept. Integration is the reverse process of differentiation. So give the heading integration and copy this one liner in your notes.
Yeah, done.
Reverse of Integration is the reverse process of differentiation. The primary formula is here, x power n. So in differentiation, we decrease the power, but in integration, we increase the power. In differentiation, we multiply by the power, and here we actually divide by the power. So whatever we have done in differentiation, we are going to do in reverse for integration. So after giving the heading, you have to copy this screen. It's better to copy in your own hand because this will be a new title from today.
Sir, will we be given the formula in the exam sheet?
This is actually, you asked this also before. Actually, for this you can say that some formulas are given. And majority of them, which you are normally hearing, majority of them you have to memorize the main formulas. All of them should be memorized. So I show you that they give a very limited formulas. So these are the formulas. These are the formulas they give actually in the exam. These are the formulas they give it in the exam. You can see from the screen that these are the formulas they give it in the paper. It includes some very simple formulas and some regular formulas. This is the list of formulas they give. That's all. Some of them already you know, some of them are helpful, but quadratic formula and these are formula, obviously they have no big advantage. So this is the formula sheet. So now we have mentioned that integration is the reverse of differentiation.
Yeah. Sir, you're not presenting.
Hmm. I have stopped it. I'm sharing the screen now. Just a minute. Formulas given in the exam. That will be actually a sheet in our record. And we are back here. Okay. So integration is the reverse of differentiation. Look at this screen. Integration is the reverse process of differentiation. In integration, power of a variable increases by 1. So when you integrate, actually you are updating a variable. So you have to copy this. Hmm. For example, 2 upon 3. For example, look at this example. X square becomes x cube upon 3. Under root becomes first x power half, then plus 1 upon the same added power. Acha, the example on the left hand side is very significant because this is an example, this one, that has no variable. It's only 5 dx. Now, integration is like other functions in add math or higher math have some formal symbols. So this is a symbol for integration. This is a symbol for integration along with another parallel thing, dx. So these are two formal symbols. So when you integrate a function, so suppose I write x dx, so I will know that this is a symbol, only this is the function. So I will apply the integration here. I will add the power by 2 and plus c. Now c is a constant. This is another thing which is new, that while you're writing c is a constant. The first concept should be clear, that integration is the reverse of differentiation. Second concept which is necessary to understand, second concept which is necessary to understand that integration has two formal symbols. One is that wave sign, one is that wave sign, and second is the letter, the thing dx. They both will disappear when you integrate. So there are three concepts now. Integration is the reverse of differentiation. So you will add the power and divide by the added power. Second, integration has two symbols, the curve symbol and the dx. They both will disappear once integration is done. Third important concept, that integration has another important concept, that is C. C stands for a constant. Now, when you remember that integration is the reverse of differentiation. So you will notice that x cube, when you differentiate it, it becomes 3x squared. And when you integrate 3x square and you add the power and divide by the same number, you will get x cube back. This makes a triangle of concept, that differentiation is decreasing the power and integration is increasing the power. Lot of things like our nowadays softwares and zoom in, zoom out and other software, they work on this mechanism of increasing and decreasing function powers. Now, integration is the reverse of differentiation. The important feature is the contribution of a constant. Now, if I write x cube plus 3, and when I differentiate it, I will get 3x squared plus 0, so 3 is gone. Here comes a problem when the people who were designing this topic, they faced. What was the problem? That if we are integrating now, what was the constant? Because whatever constant is there, it will turn to 0. Because 3, 4, 5, whatever constant is there, it will turn to 0. And now if I integrate, I will increase the power by 1 and divide by the same added power. So I will get x cubed. Now the question comes, how to get how to get 3 back. Because whatever constant is there, it will turn into 0. This is a very critical problem. And the problem is there, that how you come to know that what would be the constant. So they thought for a possible solution, that if you do not know the constant, but there may be a constant, so instead of that constant, you can write C. Why? Because whatever constant was there, it will turn into 0. This is the significance of the constant C. Now, if we summarize the introduction of this topic, we again go for three important concepts. The first, integration is the reverse of differentiation. This is x power n. This is differentiation. And this is integration. Now, integration is the reverse of differentiation. Second concept, the symbol this and dx are formal are formal symbols. They will go with the question and they will disappear once the integration is done. Second point, the third point, the constant, which can be any letter. Normally it is C. So this is 1, this is 2, this is 3. These are the primary concepts of this chapter. Integration. That integration is the reverse of differentiation. Yes, the wave sign and the dx are formal symbols, and the constant c is a technical requirement, because whatever constant was there in differentiation, it will turn to zero. Now, if we go forward and we recall what was the differentiation of x, when you differentiate x, you get 1.
One.
As a rule, when you integrate one, you should be getting x, because integration is the reverse of differentiation. So it means that a number like 1 will turn back to x. So if it is 5x, it will differentiate to become 5. And if I integrate it back, it will turn to 5x. So this is my fourth concept in this topic, that integration can get a variable back if it's only a number, like a variable with power 1, x becomes 1. So 1 will become x. This is the fourth concept. So now there are total four concepts which are starting this chapter. So now you have to take a picture of this.
Okay, fine. So, sir, how do we apply these concepts when it comes to real life?
That's a very logical question, and I face this question once in every class, and this is very important to understand that how the first question before that, how maths comes in our life. So the answers are limited, obviously, and the scope of the topic requires a proper discussion. Unfortunately, these discussions are not much in demand in Pakistan, but I had a chance of making one or two lectures once I was in a college, and I got this chance because there some people were interested and the administration was interested. So there are three important points to understand. Number one, maths is like maths any type, maths of any version is like an exercise to unfold the mental power. So when you start your maths, algebra, and other things, it is actually the ability or the practice for human brain, that is like running the machine. So when you buy a new machine, you run it on smooth roads. That is the primary concept. Secondly, when you talk about algebra, these letters, x, differentiation, integration, how they are related to our life. So this was always the question. So I always answer the question with another question, that we first have to see how much our life is scientific. Normally, many people have a life which is using the things which are coming from this knowledge, not developing them. So once you, inshallah, go abroad and you come to our universities like Canada and Europe side, and these kind of research is going on, then you will know that all of this integration, differentiation is actually part of those softwares, part of those infrastructure which we see. For example, in Pakistan, we construct structures just by knowledge or just by some fundamental basis, not by any diagram or any software. We play games a lot. All of these games are using this. The very interesting example, for example, if we look at our life is an example of differentiation and integration. Half of the life we integrate, and then half of the rest of our life, when we go towards the old age, we actually differentiate. That is why you will see in medical science also they are introducing calculus. So the answer is, in a short, is very simple. All of the innovations, all of the theory work which is now going on, is actually behind the application, starting from mobile, bridges, construction, space technology, data analysis, and statistical analysis. These all powers are actually coming from integration and differentiation, starting from the famous game Angry Bird and going up to the James Webb telescope, which is there, how they actually think. The biggest example which I give my student, that look how AI work. Now people, lot of the people talk about AI. It is again an application of this integration and differentiation, because data and data interpretation always come from variables. So when you say volume of a sphere is 4 upon 3 pi r cube, and when you differentiate it, you get the area, surface area of the sphere. This is how this one example tells you that how an AI system can convert volume of a sphere into area. Like humans, it can't feel, but this is the way it can think of it because of this thing. So this is a short answer that actually this comes in our common life, but from the application side. Why we do not feel it when we travel outside? Because definitely we are not developing these things in our country. So not the students, not the teachers, we are just using it. Huh? If you go abroad, you will see these things in real working. That is why calculus anywhere, whenever you join maths in any university level, you will see calculus. And they will say that calculus is the key of all innovations going on. Now we move forward to our next concept, that y converts to dy upon dx, and dy upon dx converts to y. So it means when you differentiate x, it will become 1, and 1 becomes x. This is how we summarize this concept, that fx becomes f prime x. Then f prime x will become fx on integration. F double prime means second derivative, d2y upon dx2. This is all the symbols introduction, that what type of symbols are used. So you have to take a picture of it.
So then the reverse symbol for the second derivative is f of x.
Huh. When you integrate, you will remove the complement sign.
Okay, done. I copied it down.
Now look at this. If second derivative is given, we integrate twice to get y. For every integration, put constant like c. So now look at this working. You have to you have to take a picture of it.
Okay, done.
Hmm. Integral and dx are formal symbols. They are removed when integration begins. So we can remove these symbols. So you have to take a picture of this also.
Okay, done.
We have discussed the significance. So any constant becomes zero on differentiation. So after differentiation, the constant cannot be located. This is why we have to put the constant c to compensate for any missing constant. So a constant c is provided to compensate that unknown constant. So now you have to remember this concept, why the constant c was introduced. Exercise 20.1, the same book, exercise 20.1.
Okay, found it.
Okay, exercise 20.1, question number 1A. Examiner will use, the book will use a formal symbol dy upon dx. Now, this will be a type of, a thumb rule that when dy upon dx is given, when dy upon dx is given, it means you have to integrate. So when dy upon dx is given, your target is to integrate. So now you have to see question number 1A, copy 1A. To dy upon dx is equal to 2x cube. Remember the rule. When dy upon dx is given, it means you have to integrate. So now you have to copy this.
Okay.
When we integrate 2x cube, when we integrate 2x cube, look at the
Um,
working.
yeah, I'm done. I did
Hmm.
it on.
Now, when it is only -5, when it is only -5, it will turn into -5x plus c. Now, a function cannot be integrated in the denominator. A function should be moved up. So you have to take a picture of this.
What does it mean by that? Like when it's been stated in the question that way, it should
It
be
means
moved up.
if it is like, suppose 1 upon x square is given. 1 upon x square is given. So it means that you can't integrate it. You can't integrate it from the denominator side.
Okay.
So it means that you have to first bring it up. We used to do the same thing for differentiation also. We do not differentiate in denominator. We do not integrate in denominator. So this rule means that if you get something in denominator, you will first bring it up. For example, 2 upon under root x. Copy this question.
Okay. Done.
So now we start it. First, we make power half.
Okay. Done with that step.
And then now you will integrate, remove the sign.
All right. Okay. Done. I understood.
Now, this is actually the part E. Now, similar way, look at part number F orally, that you this was 1 upon 2x cube. So you move the number out because coefficients are not differentiated. So coefficients are not integrated. Coefficients are not differentiated. Coefficients are not integrated. So you have to see part number F orally, and you have to take a picture of it. Look it orally and take a picture of it.
Alright. Sir, when a number is in the denominator, like 2 or 3, then when you move it outside, it becomes its complete opposite, which is half in this case.
No, actually, I couldn't get. You mean that if you move the number, the first blue two.
No, I'm asking that in the denominator, there's a 2 there, so you have to move it out, and it
This is
becomes.
a formal thing. Once you get the concept that actually coefficients are not differentiated, so coefficients are not integrated. Taking it out is a formal thing, but you know that it's not going to take part in integration. That's all. Otherwise, taking it out or not, it's not important. Important thing is that the denominator 2 will remain as 2. Now look at this 6x plus 3, question number 2a. Copy this question.
Alright, done.
So now you can solve it on your own and then you compare it from the screen. This is our new chapter. So we are starting it in a proper way. So we are not going for directly the big questions because integration, like differentiation, that it is a proper topic. The only issue which we have to remember that the integration and differentiation sometimes get mixed. So people make mistake that they had to differentiate, but they integrate. So that's why we have to keep a good memory base first.
Okay, I see. Okay, done.
Hmm. So similarly, when you get brackets, you multiply the brackets. Now here comes some difference. We have a rule which is called product rule. But in integration, we have no product rule. We have no quotient rule. Now that is, you have to copy. You have to copy this question and copy the hint also.
Alright, done.
So now start it.
Okay.
Can you hear me?
Yeah.
Sorry, it was a glitch, and we multiply the functions.
Sure, I did that part, but then uh, at the very end, you'd get two of these x's. So x cubed over 3 plus x squared over 2, right?
Hmm. So,
Okay, so then I got x cubed over 3 plus x squared over 2 minus 2x plus c. Is that right?
can you repeat that? Actually, there's slight noise in the background. Can you repeat, please? You said that you got x squared plus x minus 2. I got that. Then you said something about different integration.
I was saying I got x cubed over 3 plus x squared over 2 negative 2x plus c.
That's perfectly matching. That's fine.
Okay.
Acha, now look at this part number F. It's a fraction. First, split the denominator and then integrate. A fraction cannot be integrated directly.
Okay. So when you split the denominator, it becomes 1 over x squared. Then you bring it up to its numerator form. Then it becomes x raised to the power negative 2.
Hmm. You first split it and then you bring it up. Right. This is right. So let's try this option.
Okay. Sir, but then that makes it become two different brackets.
Doesn't matter, but we will simplify it. Na? We will separate it to entities. Like this is the first step. Look at the first two steps.
Uh, I did it wrong. Uh, I
Problem.
did it.
Let's fix it.
Oh, actually, I did it using a different way that's more like simpler. It doesn't involve putting it into fractions. It just goes straight away. It multiplies it out.
How?
It's because I took it as
X
brackets,
squared
bracket
common.
2x squared plus 3,
You
bracket
took x
x.
squared common
Yeah,
and then cut x squared by x squared.
yes.
But then you will be getting the same blue.
No, but like when you're doing the expansion part of it, x squared times x raised to power negative 2, then wouldn't it be there wouldn't be anything left there, then it would be uh 2 minus 2 0 x raised to power 0 is equals to 1
No, have you started integration or this is before integration?
before integration.
No, then I'm not getting because I got the idea that you took x squared common.
Yeah, I'll just do it the fraction method.
So I think it's right.
Yeah, now
So
I got the fraction.
is it matching that because you are giving one number extra per but are you getting the same? I mean 2 plus 3x minus 2.
Yes, well now I'm getting the same.
Okay.
when you add the power, then you get x raised to the power -1.
You're integrating it now?
Yeah, I'm integrating it.
Yes, right.
Okay. Okay, I'm done. I got 2x minus 3 upon x plus c.
Okay, now we put our next concept. There is no quotient rule or product rule in integration. So in integration, we have no product rule, we have no quotient rule, we have to eventually simplify. So now you have to take a picture of this.
Okay. Alright, done.
So this is the point here. Now we move forward that we have question number 3A. Question number 3A. Now copy this question.
Okay. Sir, over here we'd be bringing up the x squared
Hmm,
and
right.
x raised to the power -2
Yes.
is how it
We will move
yeah.
x power, we will move x square up. Is it matching?
Sir,
Hmm. Now look at part number D. Look at part number D.
yeah, I can see that. Sir, the under root x outside is supposed to be the variable that is going to
Yes,
multiply
under root.
into that.
Actually, both under root x are variable. So
I'm
you
talking about the one that multiplies out, and we don't have to integrate it, right?
no. That's not a number. That rule applies only for numbers. Under root x outside is a variable. It has to be brought in the camp, and then you have to integrate it. You can't leave it like you leave 2 as a number. It's not a number, it's a variable. So it has to be integrated.
Okay. So wait, when we have a number outside, then it's not going to be integrated. But when we have a variable outside, it is going to be
Hmm.
integrated.
Yes, a variable has to be integrated.
Okay. Sir, I did it all, but I did not do the extra steps.
Hmm?
I did not do the extra steps involved for the second fraction you've written, 3, and then it's x
All
raised to
doesn't
power
matter.
3 upon 2. Yeah,
But the final answer is matching.
yes, it's exactly the same.
Okay. Now you come to question number 5. This is 5A.
Okay. Sir, I got 2x plus 2x squared minus x cubed plus c.
2x, yes. Now 5B.
Okay.
Under root should be separated.
I'm done with the before integration part. I'm just integrating it.
So now we move to our next concept. That is the concept here that when you integrate, when you differentiate, when you differentiate the equation of a curve, you get the equation of the tangent. Integration is the reverse. So now that will be our next title. Equation of curve, when you differentiate, you get gradient of tangent. And gradient of tangent, when it is integrated, we get equation of curve. So I have to copy this, a very important concept.
Okay. Done.
Now, when we differentiate a function, we get equation of a tangent. Equation of a tangent is dy upon dx, and this is m. So we also remind that x power half is under root x. X power 3 upon 2 is x under root x. X power 5 upon 2, x square under root x. So you have to copy this left hand side also.
I'm done with that, but I do not understand the part where you said x raised to the power 3 upon 2 is equals to x under root x. I don't get that.
That's basically a power method, na, that you can write x power 3 upon 2 as x under root x. You can simplify, put x power half into x. You will get the same x power 3 upon 2.
Okay.
So if you convert it, so suppose that you want to convert it back, so you will say that x under root x is equal to x into x power half. So it will be x power 3 upon 2. This will be the way to show it back. So it's actually a power method, power management.
Yeah.
Now we are on question number 6, page 435. Exercise 20.1 is going on, and we are now entering into a word problem. Find the equation of the curve which passes through the point. Now, this is an important sentence to remember. Equation of a curve. Equation, look at this, equation of the curve. So whenever you have an equation of the curve, whenever you are finding the equation of a curve and dy upon dx is given. So when dy upon dx is given, it means the question is on integration. When dy upon dx is given, when dy upon dx is given, integration, when dy upon dx is given, integration will be the question form, because dy upon dx given means they have already differentiated it. So it's a differentiated version. So you are supposed to find the integration. So first you see the question, then you will make a data of it. Okay. Now you have to see this question. This is question number 6. First, make the data. Dy upon dx is equal to x. Dy upon dx is equal to x 3x minus 1.
Yeah. And now we integrate.
Yes. First, you copy the question. Dy upon dx is given. So you start with the data and you tell the examiner that look, dy upon dx is given. You open the brackets and then you integrate the function. You see the first step?
Yes. I'm done integrating now. I'll put in the values of x.
So then you have to put the coordinates 2 comma 4.
Yeah, but what about? Okay, never mind. I got it.
Sorry.
No, it was nothing. I was talking about c, but I had to put in y
First
as
you,
well. So
first you put the coordinates of x and y, find c and put it back.
yeah, c I got -2.
So now, then put the c back.
Yeah, I did. Oh, I'm done with that. But sir, in the question, when it gives the coordinates 2 comma 4, is that supposed to be the coordinates of the curve?
No, actually, the question was basically it's an equation of the curve. So the points are on the curve. That's right. So that is why you didn't put 2 comma 4 in dy upon dx. You first integrated the function and you got the equation of the curve. The equation of the curve can take in 2 comma 4.
Yeah,
So the 2 comma 4 is on the curve. 2 comma
right.
4 is
Understood.
for the curve. Okay. So this is our integration work. We have started it, and we will inshallah continue this in our next class. Allah Hafiz.
Allah Hafiz.